Welcome back to our Power System series. During today's lecture, we are going to study the circuit analysis of a medium transmission line. Let's take a few minutes to recall what we did during last lecture. During our last lecture, we introduced transmission line performance. And we said under this umbrella, we are going to study short transmission line, medium transmission line, long transmission line, lossless transmission line, which is good. During the last lecture, we found the ABCD parameters, they are complex numbers. And we said A and D has no unit, and B ohms, C Siemens, S for the unit. And now we are going to start the actual medium transmission line. Medium transmission line between 80 to 100 or 250 kilometers, depending on your book, on your standard that you follow. Okay, let's start. If you remember from the last lecture, we said for a medium transmission line, we set some consideration to allow us lumping the shunt component of the transmission line. Okay. Let's see what does this mean to us. For a medium line, I will have this representations. This I call it y over 2, this y over 2, this will be z, r plus jx, this is vs, is, vr, ir. So into this section, what I did is I have the admittance, use that for the capacitors, because I can lump the system, I will divide them into two. And then I have the Z, Vs, Vr. Now I need to find, my aim is to find the A, B, C, D complex element, complex parameters. How do I do this? For me, I use circuit analysis, and it's a very easy, you will see, it will end up to be very simple task. Okay. In order for me to use, let's use this node. I want to call it this V2, and I will say this is V1 node. I want to call this I dash. What's I dash for me? If I take out this node, I apply nodal analysis. Remember, this is the admittance. So I have I dash, it's equal to IR plus V multiplied by Y over 2. VR multiplied by Y over 2. Okay, perfect. I define now what's I dash. Vs is across the capacitor value, which is equal to this voltage plus this voltage. Vr is across this. So now, from my circuit analysis, I have Vs will be equal to Z I dash plus Vr plus Vr. All I have to do now is I replace I dash with its value. So now I have equal to Vr plus Z I multiply with IR plus VR Y over 2. See, what I've done is I took this, I replaced this I dash with its value, and that's what I end up with. Now, I can see that, hold on a second, I will take this into, I break this, so I have Vs is equal to Vr plus Zir plus Zy over 2 Vr. Is that clear? Now, I can say that Vs will be equal to Vr plus Zy over 2 Vr plus Zir plus Zir. So therefore, from this one, Vs it's equal to 1 plus Zy over 2 Vr plus Zir. This now, similar to Vs, it's equal to A Vr plus B Ir. So this will represent A, this will represent B. Is that clear? Let's take a moment to digest what we just did. So what we have, let's look what we have. We have a circuit. This is the circuit of a medium transmission line. So what we've done is we analyzed the current at node V2, which is equal to this current plus this current. Because I'm using that admittance, this current in here is equal to VR times Y over 2, this current is IR. Then I use Vs, which is the voltage across this capacitor. It's equal to this voltage plus this voltage, which is VR, this voltage. Vs, it's equal to I dash Z plus VR. It's equal to I dash Z plus VR. I replaced I dash with its value. I end up with a relation between VR, it's equal to Vs, it's equal to VR plus Z multiplied by IR plus VR Y over 2. I did some calculations, rearrangements, and I end up with A. In my case, I end up with A, it's equal to 1 plus Zy over 2, and I end up with a B, it's equal to Z. This is A and B out of the A, B, C, D. Let's write them over here to keep them. A, it's equal to 1 plus Zy over 2. B, it's equal to Z. Is that clear? Okay. So now we already found A and B. We found A and B. Great. Now I need to find IS to find C and D. Okay, let's read this one. Where can I find any relation for IS? I look at this node. What do I have at this node? Can someone tell me what do I have at this node? Okay, I have at node V1, what do I have? I have IS, it's equal to this current plus this current, it's equal to Vs Y over 2 plus I dash plus I dash. Okay, I wanna recall what's Vs equal to. Vs equal to A VR plus B IR. From the previous one, this is equal to IR plus VR Y over 2. A and B is known to me. A and B are known to me. So therefore, I have IS in a function of VR and IR. And that's what I want to get to, isn't it? If you remember the equation, IS, it's equal to C VR plus D IR, which is perfect for me. Okay, let's put things together. Let's put things together in perspective. What's A? So now I have IS from this one. I have IS equal to Y over 2, Y over 2 multiplied by VS. VS, it's A, it's equal to 1 plus Z Y over 2 VR plus B IR Z IR. That's this component. I dash plus IR plus VR Y over 2. Is that clear? Let's take a moment to digest this information. If I go ahead now, digest this information, if I go ahead, I will end up with IS. I will end up with IS. It's equal to Y 1 plus Y Z over 4 VR plus 1 plus ZY over 2 IR, which is this represent C, this represent D. So therefore now I've already found the parameter A, B, C, D for a medium transmission line network by performing nodal analysis, or I can use also, if I want, mesh analysis into the circuit of a medium transmission line. And now I can start doing an example for a short and a medium. So far, what we covered, short and a medium. Based on this stuff, I have the ABCD for a short and an ABCD for a medium. Let's take a moment and we will solve a problem regarding the medium transmission line of a system. So let's do an example regarding the medium transmission line. We have a 200 kilometer three-phase rated at a 230 kilovolt three-phase network. I have the line impedance is 0.08. Z is equal to 0.08 plus 0.48 ohm per kilometers, and I have y, j, and I have y is equal to j per kilometers. The line deliver 250 megawatt. The line deliver, I have an SR 250 megawatt of power factor equal to 0.99 lagging. The receiving voltage 220 kilovolt. Question number 1. I need to find the A, B, C, D parameters. Question number 2. I have to find the sending voltage and current. Question number 3. I need to find the percentage voltage regulation. These are my three questions that I need to solve. Let's go one more time. I have 200 kilometers line. 200 kilometers line. The rating of the system is 230 kilovolt. 3-phase. I have Z of a line is 0.08 plus 0.48 ohm per kilometer. I have Y is J 3.33 10 to the minus 6 Siemens per kilometers. I have the receiving power is 250 megawatt, power factor 0.99 lagging, and I have the voltage received is 220 kilovolt. I have to calculate the A, B, C, D parameters. Then I have to find the sending voltage and current, and then I have to determine the percentage voltage regulation. Okay, let's start. Question number 1. Question number 1. What's A? A is 1 plus ZY over 2. That's A. Now I need to find Z and Y. Z is equal to 200 multiplied by 0.08 plus J 0.48. Y is equal to 200 multiplied by J 3.33 10 to the minus 6. Because I need to multiply by the length, which is 200. Now, A, if I put the numbers A, it's equal D, I put all these complex calculations, the answer will be 0.968, angle off. The angle will be very, very small. If you do the calculation, 0.315. This is A and D. That's A and D. B, it's equal Z. B, it's equal Z. The answer for Z will be 97.32. 97.32. The angle is 80 degrees only. That's B. So what's left is Z, is C. C, as we know, C, Y, 1 plus YZ over 4. All I have to do is put the value of YZ into this equation, and I will end up with C it's equal to 6.553 10 to the minus 4, 10 to the angle almost 90 degrees, and say it's Siemens. So now I've already found A, B, C, D value for my questions. So by doing so, basically, I almost answered question number 2. All I have to do now is put these into the equations. So now I found A, B, C, D values, which is give me a great help to solve question number 2. What's a question number 2? So that's A, B, C. Let's put C in here. C, it's equal to 6.553 10 to the minus 4 angle of 90. This is my C. VS, it's equal to A, VR plus B, IR. A is known now, VR is known, B is known. All I have to do is calculate the receiving current. Perfect. IR, all I have to calculate is IR conjugate. It's equal to, remember, the receiving power, 250, 10 to the 6, divided by root 3, 220, 10 to the 3, the angle of so the answer will be 662.7. So now IR will be 662.7 minus angle of 8.11 degrees. This is IR. So now I have A is known to me. Now A is known to me. VR is known to me, which is B, already calculated B. IR is being calculated now. All I have to do is put them down. I have to be careful. I have to put VR into phase. So VR 220 kilovolt divided by root 3. I end up with V sending. I end up with V sending line to neutral and then multiply by root 3. So now I will end up with V sending line to neutral, and the answer for this one will be equal to 155 angle 23, 155 angle 23 degrees kilovolt. This is kilovolt, not a volt, be careful, that's a kilovolt, and the final answer will be root 3 multiply, and then when I do the VS line to line, I'll multiply root 3 times 155 angle 23 degrees kilovolt. That's, I found VS. I need to find IS. I do exactly the same. I put the equation of IS. Everything is being given now. IS, it's equal to C VR plus D IR. Everything is given. Everything is given. The answer will be 635 amps for IS, the angle of minus 0.34. All I did now is I put the numbers. And I'm pretty sure you all know how to use the numbers. You can use the scientific calculator to multiply the complex numbers, which is very easy for you. What's left for me? One more element. I need to calculate this. Very easy now. I have VS, percentage VR. It's equal to, remember, it's equal to V no load minus V receiving at full load divided by V receiving at full load. This already being given. See, this is already being given. What do I have to put now? Remember, we spoke last time. Under no load, IR is 0. Remember this, under no load, IR is 0 amps under no load. So therefore, VR at no load, it's equal to VS divided by A. It's equal to VS divided by A. So under this condition, I put VS, it's equal to VS over A minus 220 kilovolt divided by 220 kilovolt. Don't forget to multiply by 100. And that will be the answer. The answer will be 26.4%. The answer for me here will be 26.4% is the voltage regulations. I hope that's clear. So let's recap before we finish this mini session as well regarding the medium transmission line network. I sketched the circuit of a mini transmission line. I did nodal analysis, normal circuit analysis. I end up with a parameter ABCD. I found ABCD, and then any questions, it will be very easy to solve for me. This will give me major advantages. I can plug in this ABCD values into any computer software, MATLAB, Excel, any software you like, and I can generate my own. Software to calculate if I have the V receiving to be that much, I receiving that much, I can calculate what's required for the sending values. I hope that's clear. Let's now take a moment and we can now do together, solve multiple questions together from our book. Let's practice.